Okay, so the steepness of a line is called slope. Okay, now we can use slope to define other things like maybe the slope of a hill or the slope of a roof or the slope of the stairs. So what this is actually telling us is the rise and run of whatever we're referring to, okay? So it says circle the line with the biggest slope. So if you looked at these three lines, this one would have the biggest, or we use words like steepest slope. The letter we use for the slope is a lowercase m. Now, a lot of times we're like, why did they ever decide to use an M to talk about something that starts with an S? Why? Because it comes from the French word monter, which means to climb or to rise, which is what we talk about with the slope, okay? So when given the graph of the line, we need to know a simple definition of slope, and it is the change in y over the change in x, and this is just rise over run. So slope is the ratio of a line's vertical change to its horizontal change. That's what we mean by rise over run. So you're always going to go up and then over, or down and then over. Okay, so today we're going to talk about how to find slope when we're given a graph. When we have a line, we need to mark some points, but we have to be specific about these points and intentional. They have to be perfect intersections. So for example, here, that line intersects perfectly right there. But if you looked at the next square, it does not. So I'm just going to circle a few that are perfect intersections. You guys see that? Okay, so now to find the slope, you start from, and I am going to teach you to start from the left, kind of like you're reading, and you find the rise or the fall. So for example, it's kind of like giving myself directions from this point to this point, but you cannot move diagonally. So if I were trying to get from this point to this point, I would go up 1 unit and over 2 units. So up is positive, down is negative. Find the run, we will always run right. So if you're consistent, some people will work from right to left. That's not wrong, but you just have to remember if you're moving down, it's negative, and left if it's negative. If you're moving up, it's positive, and right is positive. So in this case, we moved up 1 unit and right 2 units. So the rise was 1, the run was 2. So your slope of your line is 1/2. Okay. So it says later in the lesson, we will be using a formula to find the slope. So when we have just 2 ordered pairs, we can use a formula. We will often get fractions that need to be reduced. The images below show 4 attempts at finding the slope of the line above. Because you notice here, I've got different points. So the first one is if we had picked the 2 points closest to each other, we would have automatically come up with 1/2. But if you would look at the next graph, if you would have picked 2 points that were further apart, you would have went up 2 and to the right 4. Well, 2 over 4, what does that reduce to? 1/2. So note that it reduces to the same thing. You could have taken this a little further and you could have picked points that are even farther apart. You move up 3 to the right 6. But what does 3, 6 reduce to? 1/2. And the same thing with this one. To pick the points furthest apart, you went up 4, right 8, but that also reduces to 1/2. So the moral is that it doesn't matter if you pick points closest together or you pick the points furthest apart. You will, when you reduce the fraction, it will equal the same slope. Okay. So we are going to practice finding the slope of these lines. So like I said, the important thing is that you find nice intersections on your graph. So if I were looking at our first graph, I would probably pick like this one right here. And then it probably doesn't intersect nicely again until right here. You guys see those? So I'm going to start with the point on the left. I'm not going to go up because the line is not that way, but I'm going to go down. So I'm going to go down 1, 2, 3 units. And then I'm going to go to the right. So this was down 3, 1, 2, 3, 4. So -3/4. You kind of ask yourself if you can reduce it. If you can't reduce it, then that's your answer. You could. So for example, if we would have picked this point right here, we would have went down 1, 2, 3, 4, 5, 6, and over 8. But 6/8 reduced to 3/4. That's a good question. Okay. So the middle graph, I'm going to find a couple of nice points. It would say like up here, and here, and here probably. Like if I were to pick 3 points out. And then you only need to work with 2 of them. And I just picked the 2 that are closest together. So in this one, I'm going to go up 1, 2, 3, 4, and over 1. So my rise was 4, my run was 1. You may. Yep, I'm glad you asked, Milo. Good question. You can just write that as a 4. Okay, our next graph. Why don't you guys try this one on your own for a second?